Before we dive into the announcement, it's important to understand what particle accelerators are. The Large Hadron Collider (LHC), operated by CERN, is a 17-mile ring of superconducting magnets and the world's largest and most powerful particle accelerator. It represents the pinnacle of human scientific achievement. In fact, it's so powerful that it can recreate the very conditions at the beginning of the universe. But could this apparatus be used to unlock the secrets of the universe, or hold the key to something far more ominous? CERN, founded in 1954, is one of the world's most reputable research institutions. With 23 member states and thousands of scientists, it's a hub for collaboration, and CERN's innovation, the LHC, is its flagship undertaking. But it is only one component of a vast network of accelerators and experiments. Imagine a racetrack, not for cars or horses, but for subatomic particles in a race against time and space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the universe's energy at the time of the Big Bang. The collisions create temperatures 1,000,000 times hotter than the core of the sun. Thousands of magnets facilitate the proton's journey, while intricate cooling systems keep the magnets at temperatures colder than outer space. The LHC's beams are aimed and caused to collide in 4 different areas around the accelerator ring, corresponding to the positions of 4 particle detectors: Atlas, CMS, Alice, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together, they act as colossal cameras, capturing pictures taken by scientists. Of these collisions, scientists then sort through the data to find signs of the elusive Higgs boson, also known as the God particle, and other phenomena that provide insight into the universe's fundamental building blocks. By studying the microcosm, we gain insights into the macrocosm. But with every answer comes a new question, and with every discovery, it's a new challenge. The LHC is more than just a scientific tool. It's a testament to human curiosity and innovation. It embodies our relentless desire to learn and pursue knowledge, to understand the fundamental forces that shape our universe. Yet as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of probing the unknown? Could our quest for understanding inadvertently unlock forces we cannot control? In the hallowed halls of CERN, where the boundaries of human understanding are constantly pushed, a revelation has emerged that sends a shiver down the spine of even the most experienced researchers. Brian Cox, a former CERN researcher and an authority in the world of particle physics, has made an announcement that has left the world stunned. Cox's words were both fascinating and terrifying, resonating with haunting clarity. The goal of CERN's Large Hadron Collider is to recreate a miniature Big Bang. Yes, that's correct. A reduced version of the very event that gave birth to our universe. The physicist continued to enumerate the ramifications of this objective, highlighting the remarkable features of the LHC's potential for making new discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, mysterious substance that makes up a significant portion of the universe. Imagine holding the power of creation in your hands, the ability to conjure the universe's very essence. It's a tantalizing prospect, but one fraught with danger. The mini Big Bang is not only a theoretical idea, but also an observable reality at the LHC. The temperatures, pressures, the raw energy, all mimic the conditions of the universe's infancy. It's like standing at the dawn of time, witnessing the birth of existence itself. But with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go terribly wrong back in 1978. The Russian physicist Anatoly Bugorsky went through an incident that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Prodino, Russia, a malfunction led to his head accidentally coming into the direct path of a proton beam. The beam, with a force beyond comprehension, traveled through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was otherworldly. He saw a flash brighter than 1,000 suns, but felt no pain. The beam's path left a trail of destruction, burning through tissue and bone. Yet, astonishingly, Bogorsky remained conscious and walked to the hospital for treatment. The result was both horrifying and fascinating. The localized tissue death caused by the beam's path led to the loss of hearing in one ear and partial facial paralysis. Astonishingly, Bogorsky's intellectual capabilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy, but a cautionary tale that underscores the immense power and potential danger of particle accelerators. The risks of a particle accelerator, like the LHC, are not to be taken lightly. The potential for unforeseen reactions, the very fabric of space and time being manipulated. These are not science fiction, but real concerns voiced by some in the scientific community. One of the most alarming and captivating concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. A black hole is an area of space-time where gravity is so strong that it is impenetrable to light cosmic vacuum cleaners. Devourers of stars, enigmatic entities that lurk in the shadows of our universe. The idea that the LHC could create such an entity, even on a microscopic scale, is shocking to both the general public and experts alike. Could this black hole grow uncontrollably, consuming the Earth from within? Scientists at CERN have assured that any resulting black hole would be unstable and evaporate almost instantly. The mere possibility has ignited debates, fears, and a sense of awe at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the fundamentals of particle accelerators. When protons are smashed together at a rate close to the speed of light, the energy released is so immense that it warps the fabric of space-time itself. Imagine a trampoline stretched tight, and then a significant weight is placed onto it. The fabric bends and curves, and if the weight is heavy enough, it could create a depression so deep that anything in the vicinity would be drawn in. That's a crude illustration of what could happen in the LHC. In the world of quantum physics, the rules of the universe are both bizarre and beautiful. There exists a theory that extra dimensions may be concealed within reality. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational funnel that forms a tiny black hole. This enigmatic dance of particles has even caught the attention of notable scientists, especially the late Stephen Hawking. In his book, he warned of a situation in which the Higgs boson might become unstable at very high energy levels. This instability could lead to a catastrophic vacuum decay, a cosmic event that would not only destroy the Earth, but the entire universe itself. The esteemed British cosmologist and astrophysicist Sir Martin Rees also expressed his concerns about the experiments conducted at CERN in his book on the future prospects for humanity. He investigated the potential dangers pertaining to particle accelerator experiments, including those at CERN. His words were not merely cautionary, they were infused with an existential tinge of dread. He spoke of a worst-case scenario where an ill-fated experiment could create a state known as vacuum instability, which could, in theory, trigger a phase transition that would spread throughout the fabric of spacetime, resulting in a cosmic catastrophe that could engulf the entire universe. Rees's concerns were not confined to theoretical reflections. He assigned a probability to these catastrophic, albeit minor, results. But even a minuscule chance, he argued, should give us pause. The stakes are unimaginably high, and the margin for error is razor-thin. Researchers at CERN have calculated the probabilities, conducted the simulations, and investigated the theories to argue for the safety of the LHC, Brian Cox himself included, acknowledged the importance of responsible exploration, recognizing that there are a lot of worries and fears surrounding the activities of the LHC. He emphasized that there are rigorous safety measures in place, extensive reviews, and protocols that ensure the LHC's operations are carried out with the utmost care. Cox assured that the energies involved are well within what the Earth naturally encounters, and the chances of creating a stable black hole are extremely low. Even if they were created, scientists say it would be so fragile and small that it would evaporate in a flash of energy. A phenomenon that Stephen Hawking predicted would be known as Hawking radiation, a fleeting moment of cosmic wonder. A glimpse into the abyss, and then gone. Some have gone further, speculating that the experiments at the LHC may open a portal to another universe or dimension. This notion, though largely dismissed by the scientific community, has successfully captured the imagination of many and has become a subject of fascination, fear, and even folklore. What lies beyond our reality? Could we inadvertently unleash forces or entities that we do not understand? The idea of opening a portal to hell has even been sensationalized in various media, adding fuel to the fire of uncertainty. But how did this idea come to be? And what does it mean in the context of scientific exploration? The concept of parallel dimensions is not new in physics. String theory, a leading candidate for a unified theory of everything, posits that there may be more dimensions than the usual three of space and one of time. These additional dimensions could be compactified or concealed from view, but they could theoretically be accessed or revealed under extreme conditions. Now, imagine the LHC as a cosmic key releasing locks on closed doors. Since the beginning, when protons collide at energies never before achieved on Earth, they could theoretically reveal hidden dimensions or create bizarre new phenomena. In this sense, the LHC becomes a vessel for humanity's curiosity, pushing the boundaries of what we are aware of and our need for information we didn't even know to ask. As we embark on this journey of discovery, one thing is certain: the consequences of our actions are profound, and the pursuit of knowledge comes with both wonder and risk. While scientists strive to unravel the most mysterious aspects of our existence, they must also keep in mind that with great authority comes great responsibility. As the exploration of the LHC in search of knowledge continues, the stakes grow ever higher. The more we delve into the mysteries of the universe, the more we confront the unknown. And with that unknown comes a profound responsibility. Science has always been driven by the quest for understanding, by the desire to uncover the realities of existence, to demonstrate the fundamental building blocks that make up everything we see, touch, and experience. But each revelation often leads to more questions, more complexities, and more unknowns that call for investigation. The potential of the LHC is vast. It is not just a machine that accelerates particles. It is a bridge to the deepest mysteries of nature, providing us with a window into the very heart of the universe. The findings that have already been made, such as the confirmation of the Higgs boson in 2012, are monumental. They confirm the predicted existence of particles theorized decades before, strengthening the standard model of particle physics. But even more exciting are the frontiers that remain uncharted. The LHC has the potential to shed light on dark matter, the mysterious substance that makes up most of the universe's mass, but remains undetectable by conventional means. It may even offer the key to comprehending the mysterious nature of dark energy, the force accelerating the expansion of the universe. Yet, as scientists push the boundaries of knowledge, they must also recognize their limitations. The potential of the LHC for discovery is unparalleled, but with it comes the risk of unintended consequences. Each experiment conducted at CERN is an exploration into the unknown. And in such a vast and complex field, there are always risks of outcomes that could be unpredictable. Despite the rigorous safety measures and decades of preparation, there is always a possibility that something unforeseen could take place. Something not only tests our understanding of physics, but our very existence. For all its potential dangers, however, the LHC is a demonstration of human inventiveness and determination. The sheer scale and ambition of the project are a reflection of the human desire to expand beyond the confines of the known world, to venture into the darkest corners of space and time. It is a reminder that the drive for knowledge, while fraught with uncertainty, has been the engine of human progress for centuries. It is that curiosity, that constant search for the truth, that has brought us to this point, where we stand on the cusp of some of the most profound discoveries in human history. As the LHC continues its operations, the world will be watching closely. It's not only researchers who are intrigued by the collider's experiments, but people from all walks of life, drawn to the possibility of deciphering the mysteries of the universe. The LHC has captured public interest, sparking discussions, debates, and even fears about what could be discovered. Many see it as a symbol of hope, a tool that can lead us to a deeper understanding of the cosmos and our place within it. Others view it with trepidation, concerned about the risks and potential threats that could accompany such powerful experiments. As with all major research projects, the LHC represents a delicate balance between ambition and caution. Powerful tool that opens doors to new realms of knowledge, but it also requires careful consideration of the potential consequences. Scientists at CERN are acutely aware of these risks and approach their work with the utmost responsibility. Yet the very nature of their work forces them to acknowledge that there are no guarantees in science-only probabilities, its possibilities, and the constant pursuit of understanding. In the end, the LHC will continue to be a beacon of investigation. It is not just a machine. It is a symbol of humanity's unyielding quest for truth. But as we explore the vast undiscovered, we must keep in mind that with each new discovery, we may also uncover brand new obstacles, new responsibilities, and uncertainties. The pursuit of knowledge is a journey, and like all journeys, it is fraught with both wonder and danger. As we stand at the beginning of a new era of discovery, we must ask ourselves, are we prepared for what we might discover in the future? In the future of particle physics and the LHC experiments, the questions it aims to answer are as enigmatic as the universe itself. One thing is certain: the findings that emerge from this cutting-edge research will help us better understand the universe for generations to come. The LHC, as it continues its work, is not just a scientific experiment. It is a testament to humanity's curiosity, its resilience, and its unwavering determination to discover the unknown. Whatever the outcomes may be, the journey itself will leave an indelible mark on the fabric of human knowledge.